In this video, we'll be discussing about thread synchronization. Before discussing about what is thread synchronization, let us understand why we need thread synchronization. In the previous example and the previous video, we discussed about acting two threads on two different objects. It is possible for two threads to act on a single object also. So why two threads should act on a single object? We'll be discussing about that. So for example, a task is represented by an object. If a different task has to be performed by an user, then he'll be declaring one more object, or he'll be creating one more object to perform a different task. Suppose if the same task has to be performed by a different people or different persons, then they need to act on a same object, or they need to execute the same object with the same run method. So that's why it is possible for multiple threads to act on a single object. Let us consider this example. So that is railway reservation system. In railway reservation system, so every day there are several people who wants to reserve their berth. So the procedure for reserving their tickets or their berth is same for all the people. So that means same object should be executed with the same run method, so by several people. So in these cases, we'll be going with acting on a single object. That is, multiple threads can act on single object. So let us see the example. Suppose, let us assume that there is a train with only one berth present, and two people are waiting to reserve their berth. They want to reserve their berth. So two people will go to the ticket counter. There will be two reservation counters. In the first reservation counter, the clerk one will send a request to the server to reserve a berth for his client. The same way, in the reservation counter 2, the second person will go and he'll the clerk in the second reservation counter will send a request to the server to reserve the ticket for his client. Let us see what happens in this situation, to whom the ticket will be reserved or to whom the ticket will not be reserved. So let us take this example. Here I am writing one class called as reserve, which implements from the runnable interface. I am declaring two instance variables. The first instance variable is available, which is of type int, and that represents the available number of berth. I am assuming that there is only one berth available, and one more instance variable is wanted, and which is not initialized. It will be initialized during the object creation. During the object creation, I'll be passing a parameter. So by using the constructor, I am initializing that the wanted instance variable. Wanted is nothing but the number of seats requested by a passenger, or number of berths requested by a passenger. In a run method, anyhow, thread execution starts with a run method. So in the run method, I am using one printf statement. So to print the available number of berth, if the requested, that is wanted number of berth, is equal to or it is less than the available berth, or I can say in other way also, if the available berths are greater than the wanted berths, then the berth can be allocated for a requested thread. So I need to know which thread is requesting, or to which thread that request has been, or the berth has been allocated. So I am taking the name of the thread. So into the name variable, which is of type string. So thread dot current thread will give us thread dot get name method will give me the name of the thread, and name of the thread is stored to the variable called as name, and I am printing that. So along with saying that, so the requested number of berths are reserved for the specified thread. Again, I am entering into the try block, and I am using thread dot sleep. So why I am using thread dot sleep method here? Because in the reservation counter 1 as well as in the reservation counter 2, when they request for the berths, they need to print a ticket. So that delay, 2000 milliseconds of delay, I am giving it for printing the tickets. Again, after printing the ticket, so available is equal to available minus wanted. That means, in the available berths, so how many berths have been allocated, that is subtracted. Then the catch block, if in the sleep method, if any interrupted exception occurs, that will be catched by using the catch blocks. I am not doing anything here. Suppose if the wanted berths are greater than the requested, that is available berths, so then we cannot allocate berths for them. For example, if they are requesting for 3 berths, available berths are only 1. So in that case, I will be going for an else case, and I will be printing that, sorry, the no berths are available. So let us see the main method. So in the class unsafe, I am writing the main method. I am creating an object called as obj to the class called as reserve. So I am passing 1 to the constructor. That means so the wanted variable, instance variable is initialized with 1. So that means they are requesting for only one birth. So I am creating two threads with the same object. You can observe here I am passing the same obj object to thread 1 as well as thread 2. That means thread 1 as well as thread 2 are acting on the same object called as obj here. I am setting the name of thread 1 as first person. I am setting the name of thread 2 as a second person. I am starting both the threads. When T1 starts, it goes to the run method. In the run method, so it is going to print available births is equal to 1 according to us. So now available births I have initialized to 1, so it will be printing it as 1. Again, after printing 1, so immediately it goes to the if condition. It checks whether the available birth is greater than or equal to wanted. Yes, available births are 1 and wanted births are also 1. So it will enter into the if condition. Meanwhile, T2 also will start. So because simultaneous execution happens here, so T2 will go to the run method and it will also print the available births is equal to 1. So then once the thread 1 is entered into the if condition, meanwhile thread 2 also enters the if condition by checking the condition mentioned in the if case. So available births are 1 as if now. So wanted births are also 1. Both are equal. Again it will enter into the if condition. String 1, thread 1 will print its name. So that is wanted births are 1. Reserved, 1 births are reserved for the name of the first thread is first person will be printed here. So because that will be stored into the variable called as name. After printing that, thread 1 enters the try block and it goes to the sleep mode. Immediately, so simultaneously the thread 2 is also running. It also prints his name. So wanted births is 1. So births are reserved for the name 1. Again it enters into the sleep mode. The sleep mode, when the thread 1 is sleeping, so thread 2 also enters to the sleep mode. Thread 1 comes out of the sleep mode and then it updates available is equal to available minus wanted. That means what is happening? So both thread 1 and thread 2 are executing this program simultaneously. So that means the available birth, one birth is allocated for both the persons. Let us execute this program and see what will be the output of this program. When I execute this program, see available births is equal to 1. Available birth is equal to 1. It is executed for both the threads and one birth is reserved for first person and one birth is reserved for the second person. You can observe here. So that means the same birth is reserved for both the persons, which is not an actual thing, which should not happen. So same birth cannot be allocated to two persons. This is the drawback of threads. We need to solve this problem. To solve this problem, something came into the existence called as synchronization. So thread synchronization is very, very important. So this problem can be solved by using thread synchronization. So what is thread synchronization means? When one thread is acting on an object, we need to prevent other threads to act on the same object. So that is called as thread synchronization, or it can also be called as thread safe. And object on which the threads are synchronized are called as synchronized object, and that object is called as synchronized object. So let us see this example here. In this figure, you can observe see when thread 1, T1 represents the thread 1 here. When thread 1 enters the object, thread 2 cannot enter into that particular object. It should wait until the thread 1 comes out. It completes its execution and comes out. Till that, thread 2 should wait. So this is called as synchronization or thread synchronization. So this can also be given in general example. For example, if one person goes into the room, there is only one door for a room and he locks that door from inside. Till that first person comes out, the second person should wait outside the door because he cannot open the door because it is locked from inside. So this process is called as thread synchronization. Only one person can enter into the room. In the same way, only one thread can act on an object at a time. So it should wait, other threads should wait until the thread 1 or that particular thread releases that object. This process is called as thread synchronization. And how this thread synchronization can be achieved? The thread synchronization can be achieved in two different ways. One is by using the synchronized block. We can write a separate block like synchronized, which accepts the object here. You can observe here. And you can write all your statements within the synchronized block. If you write all your statements within the synchronized block, only one object can enter into this synchronized block at a time. Only one thread can enter into the object. So at a particular time, not more than one object can act simultaneously on these statements. The second way is by using synchronized keyword. This synchronized keyword can be used with any method. If you use with any method, that method becomes a synchronized method. So more than one thread cannot act on that particular method at a time. So you can observe here with respect to the display method, I am using the keyword called as synchronized. If you use synchronized keyword with respect to the methods before the method name, so that means that particular method will be synchronized. Not more than one object can execute at a time or can act on that particular method at a time. So let us see this program, how the previous drawback which was there in the previous program can be eliminated by using synchronized method. I'm not doing anything in this program, I'm doing a little bit changes. Anyway, this synchronized method, as whatever I discussed, a synchronized block which we have discussed, the first method of synchronizing the threads with respect to an object, should be written within the run method only. Synchronized block should always be present within the run method only. So within the run method, what I am doing, synchronized, it is accepting this keyword represents the current object. So with respect to the current object, I am synchronizing all my statements. So I am putting all the statements which was there, like available births, printing the available births, checking all my conditions, I am putting inside the synchronized block. If you are putting inside the synchronized block, only one thread can act on these object at a time. So not more than one thread can act simultaneously. So let us see the output of this program. I am not changing anything else, I am just adding the synchronized block. And let us see the output of this program. So when you run this program, first thread 1 will enter the run method, and it goes to the synchronized block. So there the object is obj. So with respect to that object, thread T1 is entering, and it prints available birth is equal to 1, and then it goes to the if condition. So meanwhile thread 2 is also starting. When thread 2 starts, so it goes to the run method, but it cannot enter the synchronized block until thread 1 comes out of the synchronized block. So thread 2 waits, so outside the synchronized block only. Here, so thread 1 completes its execution. It prints everything. One birth is reserved for a person 1. Again, it enters into the try block. In the try block, it sleeps for a while to print a ticket. Again, it will update the available births. Available is equal to available minus wanted. Wanted was 1. Available was 1. 1 minus 1. It will be updated with 0. Again, then it comes out of the synchronized block. Once it comes out of the synchronized block, then thread 2 starts executing. So thread 2 goes into the synchronized block. Only one thread can go at a time. So it will print the available births is equal to available variable has been updated by a thread 1. So it becomes 0. When it becomes 0, wanted is 1. So 0 cannot be greater than or equal to 1. So it comes to the else part. If condition is false, so in the else part it will print, sorry, no births are available. So this is how thread synchronization helps in solving the problem which occurred previously. So synchronization is nothing but understanding between the two threads. When one thread is acting on an object in the same time, so other threads cannot act on the same object. So that is nothing but synchronization. After first thread completes, the second thread can enter into the object, can act on that particular object. So that is about the thread synchronization. So thank you all. Thank you for watching this video. And further we'll be discussing about thread communications in